All right, everybody. We've got a tremendous list of people, and just for the sake of time, because we've got a lot to go over today. My name's Chris Knapp. I'm Vice President of Sales and Alliances here at Demand Driven Technologies. This is the fourth in our monthly webinar series. All of those recordings can be found on our website. You can also find them most likely on our LinkedIn page. We've got a phenomenal following there. Please go to our LinkedIn site, register for the blog. Lots of tremendous informational articles coming out about supply chain. We're getting some tremendous success and some wonderful feedback from the community out there. So please get in there. As I mentioned, this will also be recorded and available after the presentation. We're going to follow the normal rules. Your phones will be on mute throughout the entirety. Put your questions into the Q&A box down in the bottom there. We will ask those. If we get too many, we promise to follow up and make sure all the questions are answered after the show. I mentioned our website, our LinkedIn. Tell your friends about us. The audience continues to grow. I'll remind everybody at the end, our next webinar will be November 3rd. And we'll actually have a customer, Macro Pharma, giving a case study and actually doing a presentation on supply chain resiliency and risk management, or risk mitigation. I apologize. And without further ado, I'd like to introduce today's topic. I've asked Victor Hart, one of my senior account executives, and Wally Leasure, who is our senior solution consultant, to join us today. We're going to take a little different direction than we've done in the previous presentations, one that's near and dear to my heart. I've been in enterprise software sales for, we won't say how long, but one of the most difficult things that was always hard was validating or building a business case, no matter how fantastic the ERP or PLM or EAM or supply chain solution was that we were presenting. In the end, most customers, and rightfully so, had a hard time justifying it. They knew that it worked. Yes, it had a newer USI or it had a better platform or technology, but to actually calculate that ROI, they felt like they had to go through the entire implementation, go past live, and then some period of time to really determine that it worked. And what I love about some of the methodologies and some of the tools that we have here at Demand Driven Technologies is our ability to build that business case using customers' data for validation. And that's one of the things that we want to do today. We're not going to do it in a salesy manner. That's not the intent of this. We're still actually going to be demonstrating the resiliency of DDMRP and some of the lean theory of constraints methodologies that we have inside our software. So I hope that you enjoy. We want you to ask a lot of fantastic questions. Please put them in the Q&A and I will moderate and bring those in at the end. So without any further ado, I'm going to hand it off to Victor.
All right. Thank you very much, Chris. And thanks so much, everybody. So happy for the opportunity to be able to present to all you folks all around the world today. My agenda for the call, as Chris mentioned, we're going to be talking about how we can validate the resilience of the DDMRP methodology before ever implementing with a client. Prior to getting to that, though, for those that aren't familiar with us at Demand Driven Technologies or aren't familiar with this DDMRP methodology, I'm going to give you a little bit of background about our company as well as outline the core logic that drives DDMRP. And then we'll get into a demonstration of our ability to simulate these buffers to help potential clients prove objectively that the methodology is going to drive value for their business. So we are Demand Driven Technologies. We were founded in 2011 in Atlanta, Georgia, have an office in the Seattle, Washington area here in the US, as well as in Bordeaux, France. And when we were founded, we were the first to market with a suite of software solutions built upon this demand-driven methodology. We've implemented in well over 100 clients on 6 different continents, and that makes us very much the global leaders in terms of demand-driven implementations. We have an internal consulting team that helps implement with clients, also have a very deep bench of great partners all around the world to help us implement and provide great support to our clients, regardless of where they find themselves in the world. Here you see just a few of our clients. And what I like for folks to take away from this slide is that over our 10 plus years in business, we've proven that this demand-driven approach can be highly successful in many different industries within the manufacturing and distribution space. We've also proven that the methodology and our software is highly scalable. So some clients of ours have just a single location or only a few warehouses or plants. Other clients have all the way up to hundreds of plants all around the world. So regardless of the size and scope of your organization, you can get great value out of this demand-driven approach. And we're talking today, of course, about DDMRP, which makes up just one component of what's known as the demand-driven adaptive enterprise model. DDMRP is the materials planning component, where we're going to be reacting to actual demand to help pace inventories to what that actually is. There's also a scheduling and execution piece based on drum buffer rope logic from the theory of constraints to take those demand signals and then schedule them in the plant based on the constraints and capacity available in that plant. And then we also have a sales and operations planning piece to look out into the future to plan more strategically in the mid to long range. But today we're focused primarily on those DDMRP buffers from the materials planning piece and how can we prove that they can be effective in your business. A little bit of background. This chart shows us the inventory turns in U.S. manufacturing companies over the past 25 years or so. The sources from the U.S. Federal Reserve. And what we can see here is that those inventory turns have remained largely stagnant, despite the fact that companies have invested billions and billions of dollars in huge ERP and supply chain planning systems. The reason for that is because those ERPs essentially rely on outdated planning systems, specifically MRP. And DDMRP was developed to address the limitations that exist within those existing MRP systems. MRP is the primary planning logic that's built into all of the major ERP systems. It was introduced back in the 70s, and the logic really hasn't evolved since then. As I'm sure many of you know, MRP is reliant on a forecast. That forecast is the demand signal that we plan to. MRP is used to blow that forecasted demand down through the bill of materials for procurement, production, distribution, you name it. But that logic has one giant inherent flaw in it, and that's the assumption that the forecast is going to be accurate. Forecasts, by definition, are inaccurate. The more precise you try to be down to the item location level, the more profound that inaccuracy becomes. And so over time, by relying on that inaccurate demand signal, companies wind up with what we call a bimodal inventory distribution, which simply means at any given point in time, they have too much of the wrong materials and too little of the right. So there's capital tied up in inventory that's not turning, whereas at the same time, there are missed sales opportunities or expensive expedite costs or things of that nature because we didn't have enough material to fulfill the demand that actually is coming in from the market. Because of this, users frequently don't trust the signals that they get from their MRP system. And despite all of that money invested in the ERP system, they're still taking data out into Excel spreadsheets to try to plan a bit more accurately. Of course, that's very manual process, labor intensive, prone to user error, etc. So DDMRP was developed to address that core flaw of forecast reliance built into MRP. And it's quite simple in the way that DDMRP is different. Rather than planning on a day-to-day operational standpoint to that inaccurate forecast, DDMRP is a consumption-driven model. So we're going to rely on actual consumption and recent demand. The idea being that demand coming in from the market is the most accurate demand signal we can possibly use. Therefore, by relying on that in the planning equation, we can much more closely align our inventory levels to what that actual market demand is. In order to do this, we leverage what are called DDMRP buffers. These buffers are applied at the item location level, and they're designed to ensure constant material availability. There's 3 zones within the buffers. The green zone is what sets our average order size as well as our ordering cadence. So frequently we'll use an MOQ or minimum batch size to size the green zone. Frequently we'll use a desired order cycle. Say we want to replenish on a weekly basis, something like that. So there are various techniques that we can use to size the green zone. The yellow zone is sized to cover our usage over the lead time. So on average for a given lead time, how much of an item are we going to be consuming? And then the red zone is the safety that's embedded within the buffer. It's there to protect us against variation, be that variation on the demand side, seasonality, promotions, things of that nature, or perhaps variation on the supply side. Everybody in the world is dealing with inconsistent lead times due to the pandemic. That's a type of variation we need to be protected against. And the more variation there is with a part, the thicker that red zone needs to be to protect against it. Very similar in concept to the traditional safety stock, the big difference being that these buffers are dynamic in nature, meaning as our consumption changes throughout time, the buffers are automatically going to resize itself based on that changing consumption. As consumption increases, the buffers will increase to make sure our inventories keep pace. As consumption drops off, the buffers will shrink back down to ensure that we don't have a bunch of excess material for items that aren't moving quite as quickly as they used to. So we apply the buffers at the item location level. And this chart here, this is a screenshot from the Intuiflow software. This shows us the dynamic nature of that buffer over time. At the bottom here, these bars represent the actual consumption against the item. In this case, we're looking at the last 6 months of consumption. And then above that, we can see how the buffer has resized itself in response to that consumption. Consumption is highest during this time period, so that's when our buffer is at its peak. As the consumption drops off, the buffer starts to shrink down to ensure that we're pacing inventory based on that decreasing consumption. So over time, the buffer will resize itself based on our fluctuating consumption. And then we know when to place new supply orders and for how much based on what's called the net flow equation and where that resides within the buffer. The math is quite simple. The net flow is calculated as our current on-hand inventory plus any open supply that we have minus any qualified demand. Demand is going to qualify if it's due to be fulfilled either today or in the past, or if it's what's called a qualified spike, which is simply firm demand already in the system due out in the future, such as a production order scheduled for tomorrow, but it's due soon enough and the quantity is large enough that we want to go ahead and factor it into our net flow today. So this net flow is basically just a summary of everything that's flowing in and out of each location for each item. And then the way that it works is our net flow starts out at the top of the buffer. Over time, as we consume materials, that net flow decreases with respect to the buffer. Once it drops out of the green zone into either the yellow or red zone, that triggers an order recommendation with the quantity being enough to get that net flow back up to the top of the green zone. So in this example, we can see that the planner responsible for this item has been doing a good job of following the logic. Every time that net flow drops down into the yellow zone, the planner's accepted the recommended order to get the net flow back up to the top of the green zone. And then we can also track our actual on-hand inventory represented by this black line here, and where that is residing in the buffer. Gives us a good visual cue or visual way of judging how successfully we've been managing inventory levels over time. What we want to see is that on-hand inventory line fluctuating around the low to mid part of the yellow zone, which is going to be our target inventory range. Occasionally, it's going to be somewhat high within the buffer. You can see it gets up into the green zone in this section. Occasionally, it's going to drop down to consume some of the red zone, both scenarios are perfectly fine. That's what the buffers are designed for. We simply want to ensure that over time, we have our on-hand inventories fluctuating around that target inventory zone within the buffer. When deploying this methodology, it's important to determine where does it make sense to apply these buffers versus where do we not need them, because not necessarily is every single item in our catalog going to be buffered. There might be some make to order or buy to order items, which we want to maintain or manage with a non-buffered strategy. Or we might have some slow movers where we can use a more static min-max approach because we want to keep some inventory on the shelf, but we don't need to have that dynamic strategic buffering logic managing those items. So we need to identify where do we apply these buffers, and we call that a decoupling point, because any place where we apply the buffers, because they ensure constant material availability, we're decoupling ourselves from any kind of variability further upstream. So by strategically placing these stocking points throughout a bill of material, throughout the value chain, we can help to absorb variability, compress our cumulative lead times, and reduce the overall impact that the bullwhip effect might have on us. We see an example of that here with a screenshot of a specific parts bill of material. In this example, any item with this red, yellow, green icon is going to be a buffered item. In this case, our finished good is a make to stock item, so we are buffering it. Anything with this gray icon is going to be a non-buffered item, so it's either a make to order or buy to order part. And then this item with the black circle around it, that's our longest non-buffered leg. That gives us visibility into where we might have an opportunity to compress our lead time. This purchase part has a 25-day lead time. So if I make the strategic decision to invest in stocking material for that part, I can decouple myself from that 25-day lead time, at which point the longest non-buffered leg in this item would be this make to order item with a 4-day lead time. That helps us greatly compress the lead time. With a shorter lead time, we can still maintain our service level targets to the market without or while carrying significantly less inventory than we previously had. So this decoupling strategy helps to protect those service levels to the market, compress cumulative lead times for our manufactured goods, and dampen variability throughout that value chain. As mentioned, when deploying this strategy, first step in the process is deciding where to place those strategic decoupling points and apply the DDMRP buffers. Once we've done so, we then design our buffer profiles. A buffer profile is just a way to group like items together based on similar attributes, such as similar lead times, similar variability patterns, and the like. And the buffer profile that's assigned to an item is going to determine how reactive the buffer, particularly the red zone, is going to be to fluctuating demand. A highly steady, really steady runner does not need to have as thick of a red zone as a highly variable item. So applying the appropriate buffer profiles to different types of items will help ensure we have the appropriate settings configured. Once we do so, though, the buffers are going to be dynamically adjusting throughout time. They'll give us clear priority in terms of my highest priority items versus lowest based on how deeply the net flow has penetrated into the buffer. And then in our software, at least, it's very easy to execute on all of these recommendations in mass, or even in some cases in an automatic nature. So this all comes to deliver some really great results to our clients. First and foremost, the buffers are designed to ensure constant material availability. So high service level is the highest priority. Our clients over the years have typically seen service levels or on time in full rates in the 97 to 99% range. Via that strategic decoupling, we've helped clients compress cumulative lead times by as much as 80%. And clients have generally been able to achieve that while reducing overall inventory levels in the 20 to 45% range. So really great tangible results that can be felt all the way down to the bottom line. Here are just a few examples of, or real world examples of results that we've helped clients achieve. Have tons and tons of other case studies on the resources page in our website that I encourage you to go check out as well, if you want to find customers or stories that are in your specific industry. Now, as Chris mentioned, it's rare in the software world to be able to prove this value on the front end before an implementation, but it's very critical to us as a company to ensure that all of our clients are going to get good value out of the software, and the methodology is going to be a good fit given the nuances in their business. The last thing that we want to do is try to implement in a client that's not going to get value out of the software, because that's going to be a losing effort on both ends. And we want every single client we bring on board to be able to provide great case studies like the ones you see here. So for that purpose, we developed our simulation tool, which allows us to gather some historical data from our clients, historical demand or consumption, along with some item master data. And then we can model how this buffering logic would have managed their materials based on the actual consumption they experienced over a given time period, say the previous 12 months or 24 months or something like that. And it really helps us test the logic using their actual demand. How would the buffers have responded? Would they have protected high service levels? Could they have kept their service levels while reducing inventory levels? And then it becomes a very binary conversation of, here's the data, here's the math, is this going to work for me or not? And so that gets us to the goal of today's webinar. We wanted to do a little experiment with you folks to test the buffer based on a hypothetical part. So what we asked folks to do is when they registered for the webinar, we asked them to give us 10 days of random demand against a hypothetical inventory item. Anywhere between 0 and 500 per day was the consumption range that we requested. We took all of the responses, built them out into an entire year of demand against that item, and then plugged that into our simulation tool to say, okay, based on all of this random demand, how resilient would the buffers have been? Would they have been able to manage that variable demand, or would it have broken the model? So here is the result of that experiment. We can see in this bar chart here, just like that screenshot from the software earlier, this is the actual demand or the hypothetical demand, I should say, that everyone gave us that registered for the webinar. We've got 12 months of demand here. You can see the crazy volatility, periods of high demand, periods of low demand, etc., throughout that time period. Then above that, we see how the buffers would have sized themselves in response to that demand. We see the red, yellow, and green zones. You can see the dynamic nature of the buffer. So as that demand fluctuated throughout time, the simulated buffers increased and decreased accordingly. This black line shows us the simulated on-hand inventory level at the end of each day. And so we can see that over this time period, the buffer, despite all of that volatile demand, would have given us 100% service level. We would have generated 22 supply orders over that time period and achieved 8 turns on this material. Now, it's interesting. I mentioned we asked for folks to give us 10 days of demand between 0 and 500 units. Somebody tried to trick us. They sent in 1,200 units here. Doesn't matter. The buffer is still resilient enough to handle that spike and keep us in that good service level target of 100% over this time period. So even when folks got a little tricky, the buffers were still resilient enough to handle that. Now, in this example, we simulated this item based on a 30-day lead time. Many of our clients, especially on the purchase parts or raw materials, are ordering from overseas. Therefore, they have a lead time that's much longer than that. So we took the same demand history that we can see here and applied a 90-day lead time for that item. And we can see that even though the lead time is 30% or 300% longer than the first example, the buffer remains resilient and managed the inventory quite well. We still hit 100% service level. Less supply orders are generated and lower turns because of the longer lead time, but we still get great results out of the item. You'll notice that the buffer itself was much larger because of that long lead time. With our 30-day item, the buffer peaks at just under 20,000 units. When we add the 90-day lead time, that peak goes above 50,000 units. That's because the lead time is factored into the sizing of the yellow and red zones, so that we keep our inventory in a good position based on the actual demand, based on the lead time, and etc. So really good results here. The buffers show that they're very resilient and can handle highly volatile demand that we add in here. These are just some static examples, though. In the actual software itself, we have the ability to play around with additional parameters to test different scenarios. And so we could experiment and see, okay, what would happen if we were able to take an item's lead time and cut it in half? What would that do to inventory levels? Or vice versa, if the lead time is increasing, what would that mean for our inventory and our service levels? Or what would happen if we change the MOQ for an item or change the buffer profile that's assigned to it? We can experiment with all of those types of different scenarios in the software itself. And to give us a look into that, I'd ask Wally to take over here and jump into Intuiflow and take a look at the simulation tool itself in the software.
Awesome. Thanks, Victor. That was great. Bear with me a second. Okay, can you see my screen?
Yes.
Okay, thanks, Victor. Great. Yeah, we are a cloud-based solution, so I'm logged into Intuiflow here through Google Chrome. As Victor mentioned, we did a couple scenarios with data that was provided from our registrants today, so thank you so much for that. So let me close this in here. Victor showed a screenshot of that raw material one in the Atlanta location. We were looking backwards on how the buffer would have performed over the past year. What I wanted to do, though, is that so you can, I wanted to prove it to you. You can see the same demand pulses. Victor had honed in on our awesome registrant that tried to throw a curveball at us. But like Victor mentioned, we want to be able to have the ability to say, hey, what happens if we have a lead time change? What happens if we have an MOQ change? Do I want to look backwards? Or now with this part simulation feature within Intuiflow, you're actually able to run it forwards as well. So I could look at how we would have performed historically, or if I want to run forward based on a forecast and see if maybe my supplier is going to give me a new MOQ. How does that impact my projected service level? What is that going to do to my average on-hand inventory? Am I going to project out any stockouts? How deep am I going to get in my red zone? And I'm gathering that information from this little square box here on the left, getting some really good data. I have it run here earlier this morning. Over the next 26 weeks, how many supply orders do I think I'm going to have generated within the system? Is that overwhelming? Do I want to try to put in an order multiple? Do I want to do an order cycle where I only want to order parts once a month? Stuff like that. So for this, I'm going to actually, what I did is I took the demand history that was provided to us. I added 5% to it, and then I'm going to run that as a forecast on this particular part. Let's take a look here. Okay, as you can see, if that, bear with me just one second. I'm trying to minimize this. Pull the net flow line off here. Okay, based on that forecast that I fed into the system, if that forecast were to come to fruition against this part with its current settings, I may have an issue here. Now it's up to me if I want to take an action on that or not. So I can see that, man, my service level dips down. I've got a pretty good amount of time where I'm stocked out of this particular raw material. I'm all the way into my red zone, and I need to make some changes or maybe take an action here. So I could do a couple different things. I could run a scenario where, hey, maybe if I were to update my MOQ with my supplier, or sorry, if they were to tell me, hey, you now need to start ordering additional units, let's see what happens with that. Okay, as expected, my green zone jumps up in size, my average inventory increases. Ironically, my days stocked out, I have an improvement there, less supply orders, but I'm still not solving my problem. What we would probably suggest is doing a cycle day adjustment factor or a planned adjustment factor. I want to highlight the part sim details where we can change things like buffer profile settings. We can change things like, do I want to use an ADU to calculate the buffer, or do I want to use an FDU? Or do I want to use a portion of both, where I take a look at my forecast and I also want to look at, you know, my actuals and maybe find the sweet spot there for what's going on in my environment. Was I just notified about a lead time change? Like Victor said, on a daily basis at this point, we're talking to both prospects and existing customers that are having lead times all over the place. And I think for the buyer or planner or manager or strategy person that wants to get in and see what is the real world impact for my environment, for my parts, this is a really, really great way to do it. I'm going to jump back out of the simulator. So we took a look at just a particular raw material or a particular part. Through the S&OP tool, what you can do is run this at more of an aggregate level. So I have that same forecast that I loaded. I ran it through here, and now I have a series of reports. We have our projected supply report that I could turn over to my vendors as a projected need, right? Or my component level forecast, so my suppliers know what I'm expecting. My projected inventory report gives me the visibility into how are my buffers going to perform, again, if that forecast were to come to fruition. Am I going to have issues? You've got some really great visuals here as far as, you know, setting alerts and alarms for, do I want to take an action within this relevant range or not? If it's something that is out or occurring 6 months from now, is it worth me investing in or not? But once you have that time to focus on scenarios like this and make decisions at a strategic level, I think it's very, very, very powerful. I mentioned earlier about the cycle day adjustment factor. What I did for this particular, that raw material, I jump back here. So, right, we looked at this raw material in my part simulator here. Looks like we're going to be experiencing a stock out, looks like potentially early January here. And I'm able to see that just by hovering over here. A lot of good data points here based on the daily demand or the weekly demand that was entered for the forecast. I created an adjustment factor here where I just titled it promotion ramp up, right? So based on what I'm seeing, you know, the sales team said, hey, we're expecting to have these units flying off the shelf at this time. So I want to go ahead and prep that raw material for that. You can create an adjustment factor. You can either apply it to the yellow zone or red zone. You can add a start date and an end date. You can have it where there is no end date. You can do a coverage in either pieces or units, or you can have coverage of days. So if you wanted to just apply a blanket 100,000 units over a particular time period, great. If you wanted to apply 15 days of coverage because you have some digestion on the forecast that you were provided, that's also available to you. Go back over here. Oops, bear with me. Well, try it this way. Okay, that was our cycle day adjustment factor. Let's say I want to now apply that to a particular part. Within the part editor, again, very, very easy. Things are able to be locked down based on permissions, but let's say I have an admin or I'm responsible for this part. I want to apply that adjustment factor to that particular raw material. I can go into that particular part's details. I apologize, my Zoom settings are playing havoc with me. So here we are within the part editor itself. I'm able to do things like adjust that part profile. If I wanted to apply that adjustment factor that I had created, I can go in here. Here's that promotion ramp up that I had done. I can save it. I want to accept my changes. All set. I would then be able to go back in and run that scenario. You can also do, back in that part simulator, you have the ability to add adjustment factors like that and see that at a granular level. The reason I wanted to show it at, maybe at a higher level here is that if you wanted to apply it across all parts from a particular supplier, let's say you have Chinese New Year coming from a particular supplier, you want to go ahead and ramp up inventory for the items that you're receiving from them. You can do it at a category level. I know that's a lot of the planning conversations that we're hearing now, is that executives, managers, planners, buyers, they want the ability to group items and not have to go line by line where appropriate. So it makes people's lives easier and a little more focused. Another thing I just wanted to point out to you here is on the same. So we talked about the projected supply. I can use that as a report out to my suppliers as far as a forecast at a component level. Projected inventory, that's where we were able to identify, hey, look, we may have an issue if I'm in the buyer seat or the planner seat. Do I want to take an action? Do I want to apply an adjustment factor like we discussed? Do I want to have a conversation with the forecasting group and say, hey, is this going to come to fruition? We have reports where you're able to see any usage oddities. So is there expected usage increases? Again, just better information to have people make good decisions. We also have a projected buffer trend. So I think, as Chris alluded to early on, how will my environment perform with this methodology? Is this a fit for us? And one of the things that we can provide is say, hey, look, based on what we're seeing, 50% of your parts are a good fit. 80% of your parts are a good fit. This is what we would expect your entire on-hand inventory value to be if you would have gone down this road. This is now we can roll it forward and say, hey, based on the forecast that you've received, if we wanted to put it into the S&OP tool, we can run a projected buffer trend and say, hey, when will we align with our expected average on-hand inventory or our target on-hand inventory? And with that, I just want to flash one more at you. I know it's hard to imagine, when we only show 2 parts, I think sometimes people think, well, hey, this is too simple. This isn't going to match up to what I'm living with. I'm responsible for 1,000 parts. I need to really get into the volume. And as Victor alluded to with our customer portfolio, we have customers managing several hundred parts in a single facility, as well as hundreds of thousands of parts, in facilities across the globe. So really, really scalable and really lots of very, very exciting things on the road here. And we'd love to talk to you more about it, and excited to see what's coming down in the future. So with that, Victor, I'm going to go ahead and kick it back to you.
All right, awesome. Thanks a lot, Wally.
Yeah, you bet.
All right. Well, that is about all that Wally and I had planned to cover in the session today. Gives us some good time for Q&A here at the end of the session. If you'd like to learn a bit more, see a product demonstration of any of the modules within our suite of solutions, please reach out to us. We would be thrilled to have the discussion with you. Or if you'd like to take the time to pull your data and then really put this methodology to the test, just like we've done here today, please reach out. We would love to help you explore the methodology here in more detail. So with that, Chris, turn it over to you, see if we have any questions.
We do, and I appreciate everybody that's been sending those in the Q&A box. Please, you still have time to do that. I'll read some of the ones that I've already answered. Olivia asked, is Intuiflow independent from a MRP, or can it integrate with one? Gentlemen, I took the liberty of jumping on that one. Intuiflow can work with multiple ERPs. It can work in concert with existing MRP or other supply chain IVP solutions. My reply was, we're starting to see some very mature organizations. I think some great system integrators that are actually starting to recommend to certain organizations where appropriate that you can find methodology maybe ours works very well for some of the facilities or part of the inventory, and other methodologies from my competitors work tremendous at some of the other facilities. I think that in the end, building that superior solution is what's the ultimate achievement. I don't think it is appropriate anymore to say one solution fits everybody, especially at some of the larger organizations. Now, at some of the smaller ones, we absolutely understand having multiple systems is very, very difficult. And I think that's at the time where you do the determination, us or an existing MRP. But happy to do that research with you. Great question. Let's see. We have a question here from Anonymous. Will we be able to put ranges on supplier delivery lead time, or must it be a fixed number? Gentlemen?
Yeah, that's a great question, and we get asked that a lot. We need a fixed lead time. So I know suppliers and lead times have been all over the map. I think what we would encourage you to do as an organization is to be conservative with a lead time. Your lead time is stored in your ERP system. That's the system of record. And then as things develop, you have the ability to hone in. You can sharpen the buffers. But yeah, I think we would encourage you to be conservative with the lead times in the system because they're so critical. And then we would dial them in.
Yeah, and if I can add on to that from DDMRP ongoing management perspective, the lead times are going to fluctuate throughout time. Suppliers are never going to be perfect. That's that kind of variability that we talked about. And so if your lead times, or the more inconsistent the lead times are, the more protection we need to build into that red zone. The thicker we need to make those red zones to protect us against that. We get clients ask us in implementations all the time if they can use a dynamic lead time versus static. And we pull directly from the ERP system, but our recommendation is always to use that static lead time. To one example of a specific ERP that I'm familiar with, they have a dynamic lead time calculation, but it only averages out the 3 most recent receipts. And so if you have one anomaly there, it can drastically change that lead time calculation, which just makes the system a lot noisier. And so we always recommend sticking with that static lead time.
Yeah, now with that new part simulator functionality, as you saw, right, if you wanted to go through some lead time scenario examples or see what is that impact, and what does that do to my expected average on-hand inventory, I think that's a great tool to do it.
All right. We did have another person put in the question, didn't go much further than experiment. So if you could add a little bit more detail to your question, if it's, can we experiment with the system? There's lots of things we can do, but if you send me more detail on the question, I'll ask that to the group. Got a couple of others. Brittany from Cumming wants to know, how many parts do we need to give you for a simulation?
As many as you can. I've had clients send over 10 parts that are maybe their 10 most critical or are representative of different product categories or different types of parts. I've had clients send over tens of thousands of parts. The more we can get, the more types of parts, the more, I think, representative it would be of the overall business. So when we look at the simulation, we were looking at individual items today. The simulation tool will also take that up to an aggregate level. So we could show at the part level, at the category group level, or all the way up to the entire enterprise, what the simulated service levels, inventory levels, turns, et cetera, would be. So I think the more data we can get, the more representative the simulation will be, and the better it helps us in the evaluation.
Good response. Let's see. Dan from Michigan wants to know, how long does a simulation take to run?
Once we get your data, it takes us approximately 48 hours. So if we get the data from you, we can get back in front of you in about 48 hours.
Wonderful. We might want to put a little bit more leeway on there in case you guys get busy, but appreciate the honesty there. It does take some time, I think, for us to do the analysis, and I know you guys are often very busy, as everybody that's out there, but fantastic turnarounds have been realized.
The tool does the work, Chris.
It just does. Gentlemen, is there any cost to the simulation?
Zero financial cost.
Excellent. As I said, folks, I think this is a tremendous opportunity. It does not take that long, and in the short run, gives you absolute proof whether or not the methodology can work at your organization.
Chris, if I
please.
could, there's one additional. Unfortunately, I kind of glossed through it, but when we got that data that Victor was showing us, we also have another feature called the Smart Buffer Profiler. So I think we get asked sometimes, hey, if I was to onboard with this, or if I wanted to, get up and going, do I need to go through my 15,000 parts and assign buffer profiles and identify what items I want to buffer or not? Part of our client success team goes through, we assist, we handhold with a lot of that stuff, and then we leverage our tool, the Smart Buffer Profiler. So we already have analysis going on in the background to not only get you off the ground, but then to also do reviews. So the Smart Buffer Profiler is always running in the background. If as part of your monthly or quarterly cadence, you wanted to go through and reanalyze the buffers, hey, this is what was assigned based on what's been occurring in the past 90 days. The Smart Buffer Profiler is recommending some changes here and there. Do I want to accept those or not? You could then feed that into the part simulation tool. What is the financial impact? What is the carrying impact? So I forgot to mention that in my demonstration there, but just one other thing for the group.
Excellent. It looks like we might have some existing customers on online here. Is the part simulator available now?
It is being rolled out as we speak, yes.
Okay. And then the last question I have right now, if I can't get my demand history, can I still see a simulation of my parts?
Yeah, we need your demand history. We could take a look at a forecast potentially and maybe work with you there to see what we could do. But yeah, anytime we try to run these simulations, we would like to take your actuals. So yes, we do need demand history. Not to say we couldn't get creative with you. If we've been talking to prospects that are either recent onto a new ERP system where a decision was made to not bring over history from a legacy system, I would be happy to talk to you more about that and maybe come up with a creative solution. But ideally, we would have some sort of a demand history from you.
Great. I think that just about wraps up the last of the questions. Folks, you've got several ways to reach us there. Victor's email's on there. Please don't hesitate to reach out to us directly. Once again, this is the fourth in our monthly webinar series. Went a little bit into the product this time. Hopefully you continue to join. Follow us on our LinkedIn profile. We've got a fantastic series of blogs, educational information that is going out there. The resources tab of our website. We put all of the recordings, all the white papers, the customer testimonials, everything that you want to know about the solution in DDMRP. Don't forget, the next webinar is November 3rd, same time, same place. We'll be sending out information on that. It will be a customer case story. Macropharma will be joining us and taking us through how they handle resiliency in the supply chain using DDMRP. So with that, Wally, anything else that you'd like to throw out?
No, looking forward to continuing discussions with folks. Hopefully this was helpful, and we'll talk to you soon.
Victor?
No, just thanks so much for joining, everyone.
Gentlemen, thank you for your time. To all of the folks out there who took the time to join us today, I'm going to give you 10 minutes back that you had scheduled to be with us, but a phenomenal session. Thank you all again for your time. Have a great rest of your evening, afternoon, or morning. Take care.
Thanks, everybody.